All right, welcome back. So in the part one of this video, we look at the interface for ERC-721 contracts. So that is the NFT contract. So in this particular video, we are going to go through the smart contract for an ERC-721. So I'm going to go line by line, explain everything in the contract and everything you need to understand in the contract. And you see how we implemented, how the interfaces we saw were fully implemented. Now, this, why trying to, this code base is more of what you have in the Open Zeppelin. So I went through the Open Zeppelin docs, try to understand the code very well. Then I abstracted a lot of things. You know, if we are going through Open Zeppelin docs, maybe one contract might lead you to another contract, and that is for you to understand what is happening in a contract. You might need to either go down, or even go to another contract to see what is happening. So in going that, for a beginner or for someone who is actually still trying to understand the whole thing, it might actually be tedious, and at some point you might actually lose interest. So that's why I've tried to narrow everything down. So I've simplified everything. So everything is in one contract. So we are going to go through it line by line, understand how everything works. So I believe at the end of this video, when you look at any ERC-721 contract, you can actually know what is happening. So let's get started. So the first thing in line 5 and in line 6, we are importing libraries. So we have the strings and address library. So we are still going to see where we are using this library. So we've imported the library. So here now we are using the library. So here we are using the A for B pattern. So using address for address. So what this is trying to tell you is that once I have an address, you can actually call any method that is implemented on this library on the address. So let's go to this address library and see some of the methods that were implemented there. So once you hold your control key, you double click. Hold your control key, you click. So it's going to take you to the address library. So one of the functions we have in the address library is contract. So now we are going to make use of this particular function or this particular method when we are calling the safe transfer form. So this is going to be called on ERC-721 receive to check if the contract is an NFT contract that implements that particular decision. So if it's an NFT contract, it's going to check if the length is greater than 0 and the whole of that. So we are going to see that when we go down into the function. It's just me trying to show you some of the methods we can call in the library imported. So there are still other methods, same value and the whole of that. So basically what line 10 is saying is that once I have any address in this contract, I can call any method specified inside this address library on it, and the method will be valid. Now, the same thing for strings. So once I have any uint25cs, I can call any of the methods specified in this string library. So one of the methods is to string, another method is to string, but now it's another so that is function overloading. So to heads and the whole of it. So once you have a uint25cs, now take note, this is uint25cs. So that means you can't call this string on uint8. You can't call it on uint16. You can't call it on uint32. So it must be uint25cs. So if you now want to use it on another destination, you have to define it for that particular uint. So since it's defined here for uint25cs, so that means the method will only be available on your 256. So we are still going to see this guy maybe when we go down. You get, so okay, like I have it as in 256. Okay, let me see if I change this guy at Unit 8, it's going to throw me an error because we already have a place to use it in the code. So let's go down and see the, okay, let's see, just save. Okay, we can locate the error here. So we are using it on this token ID. You get, so we are using it in this token URL to convert the token ID to string. Now it tells me that the member to string is not found or accessible after this because I defined the library for Unit 256, but my input, I defined a library for Unit 8 above, just so we change it to Unit 8. But here, if you watch here, my input is taking 256. So to make sure that what I have in my definition is the same thing I'm taking, is to change this guy to Unit 8. So if you change it to Unit 8, the error will go away. So this is just to tell you that if you are using it for unit, so whichever unit you define is what you are going to call the method on. So just know that. Just know that. So these are what line. Yeah, so that is line 9 and line 11. So these guys, they are giving all the structure for the library and the variables we can actually call this library. So on line 13, on line 14 and 15, we have the state variable that stores the token name and the token symbol. Remember, when we are looking at the ERC, that is the interfaces, we look at the metadata. So in the metadata interface, that is where we have the, let's go back. In the metadata interface, that is where we have the token name and token symbol. So that means this function now, we are now implementing it. So once these are state variables, so once you create this NFT, the name you give to the token and the symbol you give to the token will be stored in this variable. So anytime you call the name function, it comes here and fetches it. Now we have mappings. So on line 18, we have a mapping of an address, which is, we have a mapping of unit 256, which is the token ID, to an address, which is the owner. And this guy, it has a private modifier, which tells you that it can only be accessible within this contract. So you can actually change it to public or whatever. So this maps the token ID to address, and it stores the owners. So token ID to address, owners. So this particular mapping, we are going to implement it in the owner of function. So as you go down, you are going to see the owner of function, which is going to take the token ID as key and now return the address. Now remember, when you have your mapping, the first mapping is key to value. So mapping is key. So here now in 256 is the key, while address is the value. So once you have the key, you can actually get the value. So that is how mapping works. So that means this function is going to accept the key. So with the key, you can actually get the value, which is the address or the owner of that particular NFT you are trying to call the owner of method on. So in line 21, we have another mapping that maps an address to unit 256. So what this guy does is it maps an address to token count. So like me, another way I like to define my mapping is I have what I call name mapping. So at times in my contract, I like to name my mapping. You get, so you name your mapping. So this address of the owner to token ID to token count and the whole of that. Yeah, but for the sake of this, I think I think Solidity, the recent Solidity version, it's actually allow you to name your mapping. So So line 21 is mapping of the owner to the token count. So once you do this, you're going to return the balances of that particular address. So you are going to use this mapping when you be implementing the balance of functions. So it's going to take an address as key and now return the number of token, that is the token count as value. Then we have another mapping that maps the token ID to address that is the approved user. So what this guy does is once you call the get approved and passing the token ID as the key, so it's going to return an address. So it returns an address. So this function, we are going to see this function as we go down. So it's going to return an address. So that is token ID to address. So me, I like to name my mapping so that once I see it, okay, I know that this is this to this. So that's why you have, okay, this is since my key is token ID. So token ID to address. You see these ones here, since my key is token ID, this token ID. So here now, my key is address. So that's why I have address to token count. So that is just the convention I love using when naming my mapping. So we have another mapping. So this a 2D mapping, or what we call nested mapping. So this guy is going to take the address of the owner as the first key, take the address of the operator as the second key, and returns a Boolean. So it returns either true or false. So it's false by default and true if the approve is true. So that is owner to operator. So owner to operator. So it maps the owner to operator and return true if the operator is approved and also if that is owner. So we are going to see the function when we'll be implementing the is approved for all. We'll be looking at is the approved for all that is going to take the address of the owner and the address of the operator. So that is that about some of the state variables we have in the ERC-721. Now let's go down to, we have the events just as we saw in the interface. So events are pretty simple to implement. So these events, they are installed in spatial data location known as the log. So the events, they help you especially in the front-end part to know what happens so that, okay, as you are changing the state, you need to alert user, okay, this is what happened. And it's always a good practice whenever you are changing the state of the blockchain, you get emit an event to tell listeners or users on the UI what is happening. So events are very, very useful. So at any time you want to write to a state or change state, once you are creating a write function, always do well to create an event for it. Yeah, so these are the ones that comes with the interface. So these are the ones you must implement while you're implementing the interface. So these three, they are part of the standard. But now, based on other logics you might want to build, maybe you want to add a function for mint, for bond, or for swap or for exchange or whatever. So you need to also create events for them as well. Now in line 48, we have the constructor. So the constructor, it takes in the token name and the token symbol and initializes it and saves it to the state variable. So if you go up, you see we define the token name and the token symbol as state variable in line 14 and 15. So here now we are initializing it. So we are accepting dynamic inputs upon the deployment. So we are accepting dynamic input upon the deployment. So those dynamic input we are accepting now, we are now setting it to the state. That is, we are updating what is there in the state initially. So another way to actually do this is to just hard code the It's just to hard code the token name and token symbol here, but it's not always a good practice to hard code things. So in line 54, we have the function name. So this guy, it returns a string that tells you the name of the token. So just like I showed you earlier, the token name and the token symbol, they are part of what we are specified in the interface of ERC-721 metadata. So that is where you get the function name and the function symbol. So the name and symbol are pretty simple and straightforward. Now the balance of, just like what we have in ERC-20 gets. So the balance of is going to take an address. So once it takes the address, it queries that address and returns a uint. Now before and returns a uint. So yeah, remember, we have a mapping of the balances. We have a balance mapping above. Let's go back to our mapping. So this is the balance mapping that this balance of is going to query. But before it does that, it makes sure that the input address, that is the address we want to query, is not a zero address. So if it's a zero address, it's going to revert and say it's not a valid address, then it won't go through. But if it's a valid address, so it's going to take the owner as key. That is going to take that address as key, then return a value. So address to now the name of the mapping, the mapping is address to token count. So that means once he takes the address as a key, it's going to return how many NFT that particular address has. That is address to token count. Now we online 60 now, we have the owner of. Now this owner of is an external function. So that means you can't call this function inside this contract. So it's an external function. So external function are only accessible outside the contract. So it takes in the token ID and queries it and returns the address that owns that token ID. So now before this guy was, it calls an internal function. So if you look, we have an owner of here and we have another owner of here, but this particular owner of on line 77, it has an underscore before the name and is an internal function. So which tells you that this internal function can only be called within these contracts and child contracts. So any contract that's going to inherit this contract, we have access to this owner of. Okay, so that means you can't call this particular underscore owner of outside this that is outside the contract. So only in this contract or in the child contract. So before this guy will work, before he carry out its check, it has to call this particular owner of in 77, then passing the token ID. Once he passes in the token ID, it's going to return an owner. And remember, that owner is an address. So it now carry out a security check on that owner. That is that address. It requires that the address is not a zero address. So if it's a zero address, it's going to revert. So one, don't want you to waste gas. So no need of querying for a zero address or an invalid address. So once the address is valid, definitely it's going to return an owner. So you return an owner, remember, and that owner is an address. So once you pass in the token ID, it's going to return the address that has that particular NFT. So that is the owner of function. Now in line 83, we have the token URI. So this is one of the essential function. Now the token URI, it takes in the token ID and returns a string. It takes in the token ID and returns a string. Now, before you can get the, now, pay attention here on some of the requirements. So most of these requirements we are specified in the interface. When we are okay, let me go back to the interface. So where is token URI? So most of these guys, they are specified in the interface. Okay, so for the token URI, so before you can get the token URI, so you have to check to confirm that the token has existed. And for a token to exist, that is for an NFT to exist, it must have been minted already. Because you can't get the ID of an NFT that has not been minted or in existence. So the token URI is, it points to a JSON file that conforms to the ERC-721 metadata JSON, just what I showed you when I was explaining the interface. So basically, it contains all the necessary details about the NFT. So once you call this token URI and once you call this function and pass it the token ID, it's going to return all the details about the NFT. But before it does that, it calls a function. This is an internal function requiremented. So let's see what this requiremented does. Let's see what this requiremented does. So the requiremented is an internal function, so it can only be called within this contract or chat contract. Now, this requiremented now calls in another function that exists, which is still another internal function. So the exist, what the exist does is that it calls the owner of method using the token ID and make sure that it's not a zero address. So if it's not a zero address, so if this guy is valid, then requirement will now check. The check on requirement will now be carried out. So requirement now takes the token ID and check that it exists. So if it doesn't exist, so it's going to throw an error that is invalid token ID. But before this function will be called, so before this require function will be called, it has to first of all, this particular function on 120 we have to be called first. Now, at this point, I want you to understand one thing, like in Solidity, the order of arrangement of your function that actually matter. So you can actually pull your function maybe top down or whatever, unlike what we have in JavaScript. So in JavaScript, for you to call a function, if you want to call a function below, for you to call a function generally in JavaScript, you must define it first. So you can't be calling a function that is below another function. So there is, will I say, a hierarchy of function call in JavaScript, but in Solidity, you can spread it, call it anyhow. The main thing is for that present function you want to call, any function is referencing must be satisfied first. So this requirement, once this requirement is true, so it now calls the base URI, which is another internal function. So the base URI, it returns an empty string by default. So that means by the time you've uploaded your metadata to IPFS or Penata, you've gotten the CID, that is your base URI. So you need to replace this string with that content. So we are still going to see how we do that, because after this video walkthrough, we are going to build an NFT and see how this guy works. Then, so the base URI is used for computing the token URI. So if set, the resulting URI for each token will be the combination of the base URI and the token ID. So this guy is empty by default and can be overridden by child contract. So here now we are defining a memory variable that is a local variable called base URI. So once we call this underscore base URI, so whatever that is returned in this function will be stored in this particular base URI now. Now, it has to carry out a check using ternary operation. So it converts the base URI to bytes and check if the length is greater than 0. If the length is greater than 0, it's going to do ABI.encode pack, that is packing the distance of the base URI and the token ID. Then call this dot to string. Remember, this dot to string is from we get it from the string library we imported. So this string library gave us access to the .string method. So the .string method is defined in this particular library. So you can actually go through it and see what it does. So that is actually what is happening on which line is that? Which line is that? Which line is that? Which line is that? All right, so that is exactly what is happening on line 94. So the token ID you are getting, you are calling .string to it, converting it to string. Then you typecast everything be typecasted to string. So the end of this operation, everything after the end of this operation be typecasted to string. Then this is ternary operation. So if the length is greater than 0, then you check if this is true. Then if this is true, fine. But if this is not true, then set it to an empty string. So this is more of a ternary operation. So and the taking URI, just as I showed you earlier, is specified in the ERC-721 metadata interface. So that's about the token URI. Now, you see now the token URI, for us to understand token URI, it took us to like 3 or 4 functions. Now, if you are using OpenZeppelin, most of these guys, they are in separate files or they are down. So you might actually have some hassle going through that. So, but I've tried to actually arrange things in order so that it flows. It flows. So the next function we are going to look at is the approve. So that is line 124. So what the approve does is that it takes the address to and the token ID. Takes the address to and the token ID, just as the name implies, approve. Now this is the same thing as what we have in the ERC-20 token standard. So when you want to approve, so that means you are giving another person an access and an authority or a right to manage your NFT on your behalf, or maybe you are giving a marketplace right to trade your NFT on your behalf. So that is what this approve function is doing. So it takes in the address to and the token ID. So maybe the address of the NFT marketplace and a particular token ID, you want to give it approval to sell on your behalf or to exchange on your behalf or whatever. So this guy first of all calls the owner of function, and you know that the owner of, once you query the ID, is going to return an address. So and that address is the owner. So we now make sure that the to address is not owner. So if the to address is owner, it has to revise. So why are we doing this check here? Now, by default, if you are the owner of an NFT, by default, the NFT is assigned to you. So by default, you have the legal rights to the NFT. So it doesn't make sense you approving yourself again. So you trying to approve yourself again is trying to waste gas. So this is just a security check that tries to make sure that, okay, the receiver, the address to is not the owner. So if you are the owner, so there is no need of you approving yourself. You already have the approval by default. So you already have the legal rights. Yes, so that is what this 128 is checking. It makes sure that the tool is not the owner. Then we have on line 130, we are requiring that the message.sender is owner or is approved for all. So this approve for all is another method we are going to, okay, since we are here, let me go to approve for all and understand what this method is doing before we come back. So approve for all. So the approve for all is going to take in, it accept the address of the owner and the address of the operator. That is the third party you want, the owner want to maybe the marketplace or whatever that the owner wants to manage his or her NFT for him or exchange or whatever. So it's going to return a Boolean that is either true or false. Just like what we have in ERC-20, we have the allowances that takes in the address of the owner and the address of the spender and returns the allowances. So here, you're going to take the address of the owner and the address of the operator and return a Boolean of either true or false. So it makes reference to the owner to operator mapping we saw earlier. Okay, that is this mapping, which maps the address of the owner as the first key, then address of the operator as the second key. Then it returns a Boolean. It returns true if the owner is approved, or it returns false if the owner is not approved. So that is what line 130 is doing. So it makes sure that the message, it checks that the message is either that the message or sender is the owner, or this double pipe is all operators. So, and how all operator works in Solidity is that either of them will be true. So it's either if this is true or if this is true. Once any of them is true, this check will pass. So a course is approved, passing the owner address and passing the message or sender. So message or sender definitely is whoever that is calling this approve function. And you know that the owner of, you get it from querying the owner of that token ID. Once you query the owner of the token ID, get the owner. Then if this check did not pass, you try an error that's approve caller is not token owner, or the approve for all. So once that is done, it calls on line 135. We are calling an internal, we are calling an internal function called underscore approve. So let's see what underscore approve does. So the underscore approve, so it takes in the address to and the token ID. So this is an internal function. So token ID. So what this guy does is that it updates the mapping. So updates the mapping. All right. So that is the token ID to address mapping. You get, so using the token ID as key. So remember, once you pass in the token ID, it returns the address. So what this guy does is that, okay, this address you are passing in, so it assigns it to that mapping. So once you call the approve, after the security check, it calls this guy, taking in the address and the token ID as parameter. The function we execute. Right, so we've explained approve for all. That is 149 to 150. So let's look at get approved. So what this function get approved, that is line 162 does is that it takes in the token ID. Yeah, it takes in the token ID and returns an address. Takes in the token ID, queries that token ID, and returns an address for the NFT. So, but before it does that, it carries out its own security check. It checks that the NFT with the token ID has already been minted. So you want to make sure that you are not getting the approved of an NFT that has not been minted. So that is why it called the require minted function, which I showed you earlier. And also it now goes into the token ID to address mapping using the token ID you pass in as key. So once you pass in the token ID as key, just as we saw in the mapping, it's going to return an address. So that is what we are having. This is the mapping it's referencing. So we've defined this mapping as a state variable. So it takes in the token ID as key and returns the address. That is the approved user. So that is what get approved is doing. Now set approval for all. That is line 171. Now this set approval for all. This guy is, will I say, is a very dangerous function. Yeah, it's a very dangerous function. So you should know how you use this particular function. So it's like most of the hacks on NFT. There are a whole lot of hack on NFT using this particular function. Reason being that once you call this function, what it's going to do is going to set, that is, if you have 20 NFT and call this function, once this function is executed successfully, it's going to give approval. So it's going to give the operator approval to all the NFT you own. So that is all the NFT you own. The operator has approval. So imagine if the operator is a hacker or a malicious wallet. So that means you have given him or her the approval for all of your NFT. Unlike when you are just using normal approve that, okay, maybe you just give approve for a particular token ID. So if you are giving approve for a particular token ID, if the person is a hacker, maybe he might just maybe take away one of your NFTs or the, but this set approval for all, that means you are giving him or her approval for all of your NFT. So imagine if there is a hacking contract or a hacking, maybe a marketplace that is malicious. So you've set approval for. So what I'm trying to say is that you should be mindful of how you use this particular set approval for all. So before you use it, you have to be careful. Wash your eye very well. Understand, know what you are doing before you use this particular function. So it takes the address of the operator and a Boolean. So before this guy works, it calls underscore set approval for all, which is an internal function that takes in the, okay, let's see what set approval does. So this is an internal function. So as an internal function, it can only be called within the contract. So it takes in the address of the owner and the address of the operator and returns a Boolean. Yeah, does he return anything? No, this guy, he doesn't return anything. So it's an internal function. So once it takes this, it approves. So once this function is called successfully, it's going to emit an event. You get it emits the approval event. You get, so that is what line 171 is doing. So once you call it, it's going to call the internal function, which is underscore set approval for all, taking in the address of the message or sender, then the operator, that is maybe the NFT marketplace or the third-party address you want to manage your NFT for you, and it says the approval to true. That is, he said he sets the is approved to true. So, but before you can successfully call the underscore set approval, it carries out some security check. So it requires that the owner is not equal to the operator. So since you are the owner, it doesn't make sense you are approving yourself. So it's waste of gas. Yeah, so since you are the owner, you have the legal rights, everything is yours by default. So you trying to approve yourself, you want to waste your gas. So that is why it carries out this check to make sure that the owner is not the operator. So if the owner is the operator, it tells you to approve to caller. So it throws an error. Then it's going to update the owner to operator mappings that is setting it to true. Remember, the owner to operator mapping returns a Boolean value, and by default, Boolean value in Solidity, they are false by default. So once you call this set approval for all, it's going to set it to true. So it's going to change the approval to true. So that is exactly what is happening on line 186. So it's set the approval to true. Then on 188, it's going to emit an event on the front end, tell whoever that is listening to the log, okay, this is what has happened. Then we have the transfer form. Now, this is just like what we had in ERC-20. Now, for those of you who've not watched the video series on ERC-20, you can always check out the channel that is on before thereabout. Yeah, I made a video on ERC-20. So I dissected the ERC-20 just the same way I did here, but I first of all started the code from scratch, then explain the code line by line as I'm explaining here as well. So the transfer form, it allows you, maybe you are the NFT owner, to give another person right to hold the NFT on your behalf. So before you can call this transfer form, it also has some checks it makes. So it calls its approved donor method. Now let's look at what this is approved owner method is like. So the is approved owner takes in the address of the spender and the token ID. So it checks and returns whether the spender is allowed to manage the token ID. So for you to be able to manage the token ID, that token ID must exist. So that means that token ID must have been minted. So this is approved owner, gets the address of the owner by calling the owner of function. Then it checks and makes sure that the spender is equals to the owner, or that the spender is approved. That is, the approval that is approved for all is true, taking in the address of the owner and the spender, or that the get approved is equals to the token spender. So these are the security check that this internal function calls. So once this guy passes, then the transfer form function will now be successful. So this is the first requirement it does. This is the first requirement. So once this check passes, then it's going to call the underscore transfer form. Now, let me say it again. What this function does is that it's going to transfer, take for instance, if I have an NFT now, I want to send it to you. I want you to manage it on my behalf, maybe a marketplace or whatever. So this from is the owner to is the maybe the NFT marketplace you want to manage or want to manage the NFT on your behalf. Then the particular token ID, the particular ID, the particular NFT of the ID, the particular ID of the NFT. And you know that NFT, their IDs are unique. So now let's look at the internal transfer function. So it transfers the token ID that is from is the owner to the receiver or the NFT market or the operator, whoever you want to do it. So this is like you giving a third party your asset to manage on your behalf. Just like, okay, I give you a check, you get. So me giving you a check, I have the money in my account, but I'm giving you a legal right to go and withdraw a particular so amount. So, and that legal right is only valid when I have signed on the check. So that is just what these guys, this transfer from and transfer are doing. So the transfer, it takes in the address from the address to its internal function. So it requires that, first of all, carries out security check to make sure that the owner of the token ID is equals to from. So remember, when you call the owner of function and passing the token ID, it's going to return an address for you. It returns an address when you call this method. So you make sure that the owner is equals to from. So the form address you are going to pass is going to check that is equals to the owner is going to pass. Now, if it's not owner, it will revert, tell you that transfer from an incorrect owner. So that means you are not the owner, then you can't transfer. Then it's also required that to address the recipient address or the market address you are sending this to, or the whoever you are sending this NFT to is not a zero address. If it's a zero address, it will revert. Then it calls the before token transfer hook, and also checks that the owner of the token ID, okay, I think we've done that. Then once the transfer, that is after the whole check, it clears the approval from the previous owner. So once the whole check is through, then it calls the delete. That is, it calls the delete method on this mapping. That is the token ID to address. So like from the name as explained, once you pass in the token ID as key, it's going to get that particular address. So once this is done, it's going to delete that address from this mapping. That is a kind of reset the mapping. Then it also does another thing down here. Now this uncheck is trying to make sure that, okay, don't check for underflow or for arithmetic underflow or overflow. So once it clears the approval from the previous owner, so it's going to update the balance. Now, this is logical, this is common sense. So if I'm sending money to you, if I'm transferring money to you or transferring anything for you, so it's logical for, okay, me that is sending, you have to debit me. So you are going to -1 from the owner address, that is the form address, the address that is giving the approval, that is transferring from, then the address that is receiving. You have to credit the person. So you credit the person. So you have to debit the owner while you credit the person. So subtract from the owner, then add to the receiver. That is what line 248 and 249 are doing. Then once that is done, it's going to update the mapping. So it's going to update the mapping of token ID to address. Update the mapping of token ID to address. So what this, like, let me explain what this mapping does. Once it takes the token ID as key, it's going to return the address, that is the owner. So it's going to update it. So that means this address you are sending it to is going to now update it on the mapping so that at any point in time you want to query that particular NFT now using that ID now. This to now is now the new owner. No more me that own it initially because I've transferred it. So since I transferred it, you have to erase my own record. Erase my own record as the token owner. And now assign it to this new owner. So I assign it to this new receiver. So that is just what 256 is doing. So since, okay, I'm the owner of this initially, but I've sold it or maybe I've gifted it to someone. Okay, since I've gifted it, that means I don't own it again because NFTs are unique. So delete it from my address, delete it from my own history, then add the new owner to the history or the new owner to the record. That is basically what 252 is doing. Then it's going to emit a transfer event and call the after token transfer hook. So that is the flow for the transfer form. You see that for us to understand the transfer form now, we're able to go through two functions, which are the is approved or is owner, then the underscore transfer. So I believe these guys are clear. So if they are not still clear, you can always drop a comment. Can only drop a comment in the comment section. Then I will maybe do a quick short video to see explain it more. But I believe I've buttressed more on this guy. Now let's look at. So I won't be going into this. There's nothing really. Well, I see there's nothing really much to explain on them, but you just have to know them. Now, online 287. So we have the safe transfer form. Now, we have what we call functional overloading in Solidity. So when we have functional overloading, so that means we have two or more functions with the same name. Then we have the same name, but what will now be different is the number of parameters they have. So when that happens, you know that there is function overloading. So that is what we have here. We have this safe transfer form that has 3 parameters, and we have this safe transfer form that has 4 parameters. Now, the safe transfer form that has 3 parameters now calls the safe transfer form that has 4 parameters when you call it. So what this function does is that before you call this function, you make sure that you are sending an NFT maybe to, if you are sending an NFT to a smart contract, it has to make sure that that smart contract can be able to receive NFT. So that means that smart contract has implemented the on ERC-721 receive interface that we saw earlier. So since this particular guy is calling the second safe transfer, so let's go down to the second safe transfer and see what happens. Now, the second safe transfer, so this guy, it does some security check, which is calling the underscore is approved owner, which we just saw earlier. That is, where is this underscore is approved? So it's going to call this underscore is approved, and once it passes, then it's execute the so once this check pass, then it will now call the underscore safe transfer. Now let's go down to underscore safe transfer and see what this guy is doing. So this is where you actually need to analyze in this particular safe transfer is somehow good so that you don't send an NFT to a contract that doesn't receive NFT. So now this safe transfer, which is an internal function, safely transfer token from the owner to the receiver. checking first that the contract, that is recipients, are aware of the NFC 721 protocol to prevent the token from being forever locked. So it accepts data, which is an additional data. Okay. Now this internal function is equivalent to safe transfer form, just like I showed you. So, and it can be used to implement alternative methods to perform token transfer, such as signature based. Now, let's now look at the requirements. For this guy to work, the from address cannot be zero address, because you cannot be transferring from a dead address. And those to the to cannot be zero address. So most of them, the two addresses cannot be zero. Also, the token ID must exist and be owned by from. So the token ID must exist and be owned by the from address. Now, if to refers to a smart contract, now this is where the main logic for what we saw on this ERC. Let me go back to the interface. What we saw on this ERC once, yeah, this ERC-721 token receiver, which has this on ERC-721 received. So this is now where this interface is implemented. This is where this interface is implemented. So it says here that if the to address refers to smart contract, it must implement this interface, which is called upon a safe transfer. So just from the name safe transfer, you know that, okay, this guy wants to carry out some check and make sure that my transfer is safe, unlike the normal transfer or the normal transfer form. Yes, so safe transfer carries out safe transfer form. Once you call the safe transfer form, it carries out some security check. It carries out an additional security check to make sure that if it's a contract, the contract actually can receive NFT. That is, the contract implements the on ERC-721 receive function. But if you call the ordinary transfer form, it doesn't do this check. So it's up to you to know the one to use and at when. So this underscore safe transfer takes in the address from the token ID, then the data. So what it's going to do is it's going to call it's now going to call another internal transfer function, which we still come we come there. So when it calls the internal transfer form, it has to do a check. It has to do a check called the on ERC-721 receive, which is this function down here, passing the address form and the token ID and data. So if this guy is successful, it will go. But if not successful, it will tell you transfer to non-receiver implementer. So it has to check and know if you are sending to a smart contract that implements this. So if your smart contract is to receive NFT, it must implement this. If you do not implement this, your smart contract can't receive an NFT. And if you transfer the NFT using normal transfer form, it will be lost permanently. But if you now use safe transfer, it will now carry out this additional check to make sure that you are not sending to a smart contract that doesn't implement this. So the on ERC-721 receive function, let's see how it's implemented. So we earlier saw the interface. Now let's see how it's implemented. So first of all, remember that this tool is an address. Now it's going to call its contracts. This is contract is a method defined in the address library. This is the method I showed you earlier. So this, remember, we are using this address library here. So if you go to the address library, we are going to see that is contract method. So this is contract method. So it check and make sure that if it's a smart contract, it's going to return true. So that is just what is happening there. Okay. So now, if it's a smart contract, then that is the only time that all these check will run. But if he check and it's not a smart contract, then it returns true. And how do you know that it's a smart contract or is an EOA? So for it to be a smart contract, so that means it must have code. So if you check and it's a smart contract, then it will do all this other check. Call the ERC-721 receiver using the function selector. Remember, I showed you something when we are looking at interface. I showed you something about function selector, function signature, and the rest. So all those hashing and the whole of that. Okay, let me go back. Let me go back and see. Okay, I think, yeah. So the function prototype, the whole of this, the whole of the function name and the parameters are what we call the function prototype. Now, the hashing of the function prototype gives us the function signature, and the function signature is 32 bytes. Now, the function selector is now the first 4 bytes. So, and that is what this function returns. The on ERC-721 receive returns the function selector, which is the first 4 bytes. So that's basically the mathematics or the algorithm or the logic that is going here, calling the selector and the whole of that and the whole of that. Yeah, so that is that about transfer, safe transfer form. So when you call the safe transfer form, it's going to call the underscore safe transfer, and the underscore safe transfer is going to call the transfer. Then before he called the this also carries out a security check and call the on ERC and call the checked on ERC-721 received. Then the check on ERC-721 received is a function which is an internal function that now carries out a check to know if it's a contract or an EOA. So if it's an EOA, no need of you taking the function selector and read, because EOA by default receives NFT. But if it's a smart contract, you have to make sure that, okay, it implements this on ERC-721 received and the whole of that and the whole of that. So that's pretty much about the safe transfer and safe transfer form. Then let's look at another internal function, which is the safement. So all these function name that has save on them, by now you should have tried to, just from the name, it tell you what it does. So that means there are more security measures this guy gives you. So that means for me, there are more security. Yeah. So instead of me using transfer form, why don't I use safe transfer form to be on the safer side? So these are just some thought that might come to you as you interact, then it still boils down to the scenario and the whole of that. So this safely means token ID and transfer it to address. So some of the requirements is that the token ID must not exist. So you cannot mint an NFT you cannot mint an NFT ID that has already existed. So it must not exist. Also, if to refers to a smart contract, it must implement this interface also, that is on ERC-721 receipt, which is called upon a safe transfer. Remember, it's safe transfer that calls this guy. It's safe transfer that calls the on ERC. 721 receive. And it's the safe transfer form that causes safe transfer. So these are just how the relationship goes. So just stay with me. When I'm done explaining, I'm going to show you a graph. I'm going to use the Solidity Visual Developer, show you a graph so that you see how the, like, see how the whole various part tries to the interconnection or the interlink between the various nation. So that is meant, so for you to call the mint, so we see have function overloading here. So we have safe mints to, there is two safe mint, but with different parameter. So this particular safe mint call this other safe mint. Then this particular safe mint still carries out a check. It still carries out a check on that on a check on your 721 receive and make sure that it is valid. Then if it's not valid, it will throw an error that transfer to non-ERC-721 implementer. Then this mint function is an internal function, just like the way we have it in ERC. Yeah. So it means to this token that it means to address the particular token ID. So whenever you call the safe mint. So let's now look at, now we have the mint function here. Let's look at what this mint function is doing. So the mint function, it means to address the using the token ID we specified. So for it to mint, it has to require that the to address is not a zero address. So you can't mint to a dead address. So also it checks to make sure that that particular token ID has not exist. So you can't mint with the token ID that already exists. If you have to do that, it's going to throw an error and tells you that token ID already minted. So it calls the before token transfer hook. Then also check that the token ID was not minted by this. Then this uncheck, just try to make sure that anything within this uncheck code block, it doesn't check for underflow or overflows. At times, this uncheck helps to save gas and gas optimization, but at times in some scenario, it's very harmful. So that means for you to use it, you must make sure that no amount of calculation will result to underflow or overflow. So when this particular code block is done, then it updates the, so on line 414 is updating the token ID to address that is using the token ID to key. So it's going to update this mapping with the incoming address, that is the input address. Remember, you are minting. So if you are minting, it's going to update the address so that, yeah, it's going to update the address. With that address, you can actually query that address to now know the balance and the whole of that. Then it updates the address, then emits a transfer function. Then we have the bond function. So what the bond function does, the bond function is just the opposite of the main function, you get. So the bond function, yeah, will I say now the main function brings in more NFT into circulation or makes an NFT bringing a new token ID and rest. So whenever you burn an NFT, the approval is cleared when the token is born. So remember, in the approval, you're able to give a third party, an operator, access to own your NFT. Now, when you now burn, okay, when you burn, the approval is cleared. So some of the requirements is that for you to actually burn, you can't burn an NFT that hasn't existed. So that means the token ID must exist. So upon successful burning, it has to emit a transfer event because you're actually transferring to a zero or a dead address. So that is this is the logic for the bond. So the bond is just similar to what we have in the main function. Then we have this is just an interface of which we've implemented it. So I have to bring in this interface here so that I don't have it in a separate file, but this interface, we've implemented it. Let me just highlight it and go up. You see where we implemented it. On ERC-721 receive, okay? Just stay with me. Sorry. Let's see where we implemented this guy. Yes, we implemented these guys. Okay, so this is where I implemented this guy. I think on the ERC-721 received. Okay, let me just confirm that. That's what okay, yeah. So that is that guy. So we've already, we call the function selector on it. We call the function selector on it, then the value. So that is pretty much about the code walkthrough of an ERC-721 smart contract. So I believe by now, when you look at ERC-721, you can actually understand or know how everything is working under the hood. So you can feel free to explore more. Also, if you have more questions on what you feel like you don't understand, you can always ask in the comment section. I will maybe do another video to explain more. But before I go, let me show you something that I promise you. So let me bring out the visual developer. Okay. So we now see a graph of everything we've been talking about. See a graph that tries to give us the, the interactions you get. So this is one of the awesome tools, especially for guys like us who are interested in security and auditing. So this try to show you how the whole, the micro interaction or the internal connections of the whole this thing. You see that we have the interface, we have the constructor, we have the state variable that is function and function symbol, set approval for all, and the rest of that. So these are just all we've spent hours trying to go through, summarizing graph. Yet, so as an auditor or as a smart contract dev, it's always good for you to know the micro interaction. Like if you check transfer form, now our safe transfer form calls safe transfer. Now this is safe transfer form. It calls safe transfer. And it also has a link to is approved or owner. So that means before this will be successful, it has to also call this. Now you see that this approved has a link to get approved. Now transfer from has a link to, so it gives you the, the interaction, how the interaction goes, how the flow goes in the smart contract. Like if you look at the token URI, it calls the requirement because you can't get the token URI of an NFT that has not been minted. Then it has a link to the base URI. Then so that is pretty much about this guy. Then if you want to get this extension, it's available on VS Code. Just go to your extension tab and search for Solidity Visual Developer. Search for Solidity Visual Developer. So that is this guy, Solidity Visual Developer. So once you search for it, you can you can explore more, find your way around it, explore more. All right, thanks. So in the next video, I'll be walking you through how we build an NFT. Okay, we've learned about NFT, we've learned about the interface, the contract. Now let's build an NFT and host it on OpenSea and see it live on OpenSea. Then we appreciate the beauty of the whole thing. So we build both the NFT and do the scripting.